Okay, so our last video for the day, we want to do two comparisons. We want to compare the number of jobs or number of hours worked between the males and females, and then also between the people who did and didn't do sports in high school. So we'll do stat. We're still doing 2 sample T. This time, both the samples are in one column. So what that means is, like, for the males and females, all of their answers are mixed together in this third column. So all the samples are in this hours per week in a job column. And the reason that's the only column that's showing up here is it's the only one with numbers. So Minitab knows that the answers should be numbers here. And then we need to tell Minitab how to split those numbers into 2 groups. So the way we split it into groups, if we're comparing male and female, well, they have different tags in the first column. And so the sample ID, that's going to be the male versus female. So Minitab is going to take the people who answered A in the ID column, male versus female, put all of their numbers into one group, and then all the people who answered B in the first column and put their numbers into the second group. Can I do histograms here? I really wish I could do histograms. That would be nice. So all of these other setups are the same. So I think we're ready to compare them. All right. So it looks like we had 121 male, 156 female. The mean for the males was a little bit lower. It was 7 for the males and 8.5 for the females. That was not enough lower to get a statistically significant difference. Our p-value was 0.32. So for male versus female, the p-value is equal to 0.32. That's greater than 5%, which I didn't say it earlier, but I guess I was planning on using that as my testing level. So we do not have evidence of a difference. So even though the females in our sample worked more hours, we're going to just put that down to luck. We just happen to have a bunch of females who worked a lot of hours that pulled up the average. And if we wanted to know if there was really a difference, we'd use a bigger sample, or maybe it's true that there's just not that much difference between males and females when it comes to how many hours they work while they're a student. Okay, let's do the same comparison for sports, yes or no. I don't really have any reason to believe that the people who did sports in high school would work more hours than the people who didn't, but I thought it would be an interesting comparison. Maybe they're still doing sports now that they're in college and they don't have time for a job, or I don't know. I don't know why there might be a difference. Why don't we put up the box plots just so that we can have some kind of graph? I'm curious to see what that graph looks like. Okay, so all I did was change the sample IDs to be the second column that has the high school sports, yes or no, and then we'll rerun this test. So for the people who did sports in high school, the mean is 4. And the people who did not, the mean is 8.6. So that actually is a statistically significant difference. Our p-value is 0.004. So for high school sports, yes, no, the p-value is equal to 0.004. That is like a fraction of a percent. That's less than 1%, so certainly less than 5%. So we have strong evidence of a difference. And it's probably, if I had to guess, I would guess it's because the people who did sports in high school, maybe they're still doing sports now, and they don't have time for a job when they're on like an athlete ship athlete team. That takes up too much of their time. That's my guess anyway. I don't really know, but there's a good chunk of students in the sports and high school group, 46, and their mean is just a lot lower. Okay, so here's our box plot. Most of this people have 0, right? So, this box is sort of like the first to fourth, or first to third quartile. And this little like star in the middle is the median. Oh, I guess it's the mean. They've labeled the mean. So here the first quartile and the median are 0. So more than half the people have zeros. Same thing here. The first quartile and the median are both zeros. And then the top of the box is the third quartile. And then this stuff at the top are sort of the people in the top 25%. So lots of people in both groups don't have a job, more than half. But when you start to get into the top half of the hours worked, the group that didn't do sports in high school like sort of have much bigger numbers. And here's that 84 that's a huge outlier, but there's all the people who, most of the people with 40-hour weeks are in the no sports in high school group. Only one of them is in the sports in high school group, although this is a bigger group, but still like that's 7 versus 1. The second group is not that much bigger. It's 5 times bigger. Okay, but this box is much higher, so that's enough to make a statistically significant difference. Okay, so that's basically how it works. We have 3 ways of running this test. We have the summary statistics where we just type in the number in each group, the mean on each group, and the standard deviation on each group. There's the version where we have the numbers for one group in one column, the numbers for the other group in a second column, like we had when we were comparing the 2 exams. And then there's a third way to run it where all of the numbers are in the same column, but then there's a second multiple choice question that we use to split into the 2 groups in a different column. Okay, so there's those 3 different ways of running this test. And we need that to do the project. We're going to do the second version where we have the numbers from one group in one column and the numbers from another group in a second column when we run the project. So next day, I'll go through a sample project and then you can start work on that. Once you get all your data into Minitab, it's quick to run the stat test and then copy your answers over to a Word document to finish the project. So most of the work for that project is going to be set up. All right, so that's it for today, and I will stop now.